For as long as humanity has existed, we've turned our eyes to the heavens. The night sky, a source of endless fascination, has always filled us with wonder and a profound sense of mystery. It sparks our imagination and ignites a desire to understand our place in the grand scheme of the universe. It's a silent canvas, scattered with the light of countless suns, each a distant world, a story untold, a potential haven. These celestial beacons, scattered across the inky blackness, whisper tales of cosmic events and unimaginable distances. They are the building blocks of galaxies, the furnaces that forge the elements, and the potential birthplaces of life itself. On our small blue planet, a pale mote of dust suspended in the vast cosmic ocean, we've always felt the urge to explore, to reach beyond the next horizon. This innate curiosity, this relentless pursuit of the unknown, is what defines us as a species. It's the engine that drives our scientific endeavors and fuels our dreams of interstellar travel. This instinct has driven us across continents, pushing the boundaries of our knowledge and understanding. Across treacherous oceans, braving storms and uncharted waters, in search of new lands and new opportunities. And now, with the same unwavering spirit, it calls us to the stars, beckoning us to venture beyond the confines of our solar system. But the universe's scale is staggering. Light itself, the fastest thing we know, takes over 4 years just to reach the nearest star, Proxima Centauri. This mind-boggling distance underscores the immense challenges that lie ahead in our quest for interstellar travel. To cross our galaxy, the Milky Way, a swirling island of hundreds of billions of stars, would take light 25,000 years. The speed of light is a cosmic speed limit, a seemingly insurmountable wall separating us from the wider universe and the countless wonders it holds. We've sent robotic probes to Mars and beyond, exploring the desolate landscapes of our neighboring planets, but even these journeys, undertaken by our most advanced machines, take years to complete. The Voyager probes, launched decades ago as a testament to human ingenuity, have only just entered interstellar space after traversing billions of miles. This is a humbling reminder of the vast emptiness between stars, the sheer scale of the cosmic void that separates us from our celestial neighbours. Einstein's theories, the bedrock of modern physics, tell us nothing with mass can reach, let alone surpass, the speed of light, seemingly closing the door on faster-than-light travel. The dream of stepping onto a planet orbiting another star, of walking on alien soil and gazing at a different sun, has remained just that, a dream, tantalizingly out of reach. But perhaps, for the first time in human history, that dream is beginning to shift, to transform from a distant fantasy into a tangible possibility. The cosmos, in its infinite complexity and boundless potential, may be ready to reveal a new path, a hidden shortcut through the fabric of space-time, allowing us to traverse the vast distances that separate us from the stars. Our longing to break the cosmic speed limit isn't just impatience. It's a fundamental yearning woven into the fabric of our being. It speaks to our innate desire to push boundaries, to explore the unknown, and to reach for what seems impossibly distant. It's a quest to answer the biggest questions. Are we alone in this vast cosmic ocean? What else is out there waiting to be discovered? What wonders and mysteries lie hidden beyond our solar system, beyond the reach of our current technology? Thousands of exoplanets have been found, some residing in the habitable zone, the Goldilocks region where liquid water and potentially life could exist. But to truly know them, to analyze their atmospheres, to search for signs of life, we must go there. We must bridge the interstellar gulf. Faster-than-light travel would turn distant stars, once mere pinpricks of light in the night sky, into reachable destinations, opening up a universe of possibilities. Beyond satisfying our innate curiosity, it's fundamentally about survival. Earth won't last forever. Our planet is vulnerable to asteroid impacts, climate change, and the eventual death of our sun, and spreading among the stars is our ultimate insurance policy, a way to safeguard our species against extinction. Overcoming the tyranny of distance would let us share knowledge across light years, build civilizations on new worlds, fostering diversity and resilience, and connect worlds through trade, cultural exchange, and shared scientific endeavors. It would transform us from passive cosmic spectators confined to a single planet into active participants in the grand cosmic drama. The vastness that has kept us isolated for so long, the seemingly insurmountable distances between stars, could become a bridge to our future, a pathway to a brighter tomorrow. Breaking the light barrier is about more than just exploration and scientific discovery. It's about ensuring humanity's story continues for millennia to come, echoing across the galaxy. The universe's grand narrative, the epic tale of cosmic evolution, could finally include us, not as distant observers on the sidelines, but as active explorers, shaping our own destiny among the stars. The time to step out of our cradle, to venture beyond the familiar shores of our solar system, may be closer than we think, and the potential rewards are immeasurable. The dream of faster-than-light travel has inspired generations of thinkers. Wormholes, tunnels through space-time, promise shortcuts across the cosmos, but require exotic matter we've never seen. The Alcubierre drive, a warp bubble concept, would move space itself, not the ship, but also demands impossible energy and materials. Both ideas remain fascinating but impractical. Each attempt has run into the same wall, the need for negative energy or matter beyond our reach. These theories have expanded our imagination but haven't brought us closer to the stars. The challenge has always been turning elegant math into reality. Yet every failed attempt has taught us more about the universe's rules. Now a new approach is emerging, not from the vastness of space, but from the quantum realm. In 2025, a quiet revolution began, not with rockets, but with quantum entanglement. Physicists at CERN and Fermilab discovered that manipulating entangled particles could subtly influence spacetime itself. By applying electromagnetic fields to one particle, they created a tiny, repeatable distortion in spacetime around its entangled partner, even miles away. This suggests entanglement is more than a statistical quirk. It's a physical connection woven into reality, possibly through hidden dimensions. For the first time, the quantum and cosmic scales seem linked, hinting at a new way to reach the stars. Imagine a future where interstellar travel is not just a dream, but a tangible reality. Enter the quantum entanglement drive, or QED, a revolutionary propulsion concept that boldly sidesteps the need for exotic negative energy or unstable wormholes. This isn't science fiction, it's a theoretical framework pushing the boundaries of what we believe is possible. The core idea is elegantly simple, yet profoundly complex. Create vast numbers of entangled particle pairs at a scale never before imagined. Then carefully keep half of these entangled pairs safely contained on the ship within a specialized containment field, and delicately send the other half far, far ahead, creating a quantum anchor point in the vastness of space. Now the magic happens. By precisely manipulating the onboard particles, the ship subtly contracts space-time around those distant entangled particles, effectively pulling itself forward through the very fabric of reality. It's a paradigm shift in propulsion. The ship isn't pushing against anything tangible like exhaust or propellant. It's ingeniously tugging on the very fabric of the universe itself, exploiting the bizarre yet fundamental principle of quantum entanglement. And the beauty of it is that the process is entirely continuous. New entangled pairs are constantly generated within the ship's quantum core, new anchor points are perpetually created in the ship's path, and the ship gracefully climbs forward, traversing the immense gulf between stars. Crucially, the ship itself doesn't technically break the speed of light locally within its immediate vicinity. But the quantum connection between the entangled particles is, for all intents and purposes, instantaneous, making the effective speed of travel virtually limitless, constrained only by the sophistication of our technology and our ability to harness these quantum phenomena. In essence, it's a method more akin to carefully climbing a rope hand over hand than violently riding an explosion, relying on brute force. This means that for the first time in human history, the seemingly insurmountable barrier to reaching the stars isn't fundamentally blocked by the immutable laws of physics, but rather by the challenges of engineering and technological innovation. The future is closer than we think. Picture the universe as a vast trampoline, Rockets roll across it, limited by how hard we push. The Alcubierre drive tried to pinch and stretch the fabric, requiring impossible force. The QED is different. It stitches invisible threads into the fabric, leading far ahead. By tugging these threads, the ship creates tiny dimples in space-time, rolling forward as the surface changes. The magic is in the instant connection, cause and effect with no delay. The ship persuades space to move for it, not through brute force but finesse. We're not conquering the universe, but learning its secret language and asking for passage. If the QED can be built, it will transform humanity's future. The nearest stars could become months away, not millennia. Proxima Centauri and other exoplanets could be explored up close, not just through telescopes. Scientific discovery would explode, studying alien worlds, black holes, and the origins of life firsthand. The technology would drive innovation on Earth, uniting us with a shared purpose. The challenges are immense. The effect is still microscopic, and a working starship is decades or centuries away. But for the first time, the path is open. The wall is breached. The interstellar age is now an engineering problem, not a fantasy. The stars are within reach. The universe has always waited, inspiring us from afar. Now a key has turned. A door to the stars is cracking open. The journey ahead will demand our best ingenuity, courage, and unity. Each experiment brings us closer to making interstellar travel real. The stars are no longer just distant lights, they're destinations. The story of the cosmos is ours to join. Follow along as we take our first steps into the vast night. The journey has just begun.